Hello, so today we're looking at transformations of trigonometric functions. So let's have a look at what we're asked to do. So we're asked to graph the following functions. Okay, so these are some interesting functions. So we have y, in part A, we have y equals cos theta, B, y equals sine theta, and C, y equals negative cos theta. Okay, so why don't we start by drawing some axes? Let's do one period of each of these. So we've got our axes. Let's mark off one period worth. Okay, so a period, one period for sine and cosine, or the sine and cosine functions, 360 degrees or 2 pi radians. So I will mark things off in degrees, but we also know that it's 2 pi radians. Good. And then we're going to divide everything into quarters. We're going to mark off our amplitude or maximum and minimums and label our axes, y and theta. And now let's start. Let's pick some colors. So for cosine at 0 is, what do we have here? It's 1. At 90 it's 0. 180 it's -1. At 270 it's 0. And 360 we're back at 1. So I'm going to join the dots with a nice curve. Good. And this is our cos theta. So now part B, let's pick another color. Let's pick, I don't know, pink, or let's do yellow. That's 0 degrees, sine is 0, 90 it's 1, 180 it's 0, 270 it's -1, 360 we're back at 0, and let's join everything with a nice smooth curve. And the yellow curve is y equals sine theta. All right, so now our last one, y equals negative cos theta. Pick another color, purple. So we're going to look at our cos function, our blue one, and we're going to reflect it in the horizontal axis. So that's what our negative sign does. It's a reflection in the horizontal axis. So our 1, so when theta is 1, we now have -1. Theta is 90, we're still at 0. Theta is 180, we're at 1 now. 270 stays at 0, and at 360 we drop down, we reflect down to -1. So let's join everything with a nice smooth curve. Our purple curve is y equals negative cos theta. Great. Okay, so let's see what we have next. Graph the following functions. So in part A, we have y equals sine theta plus 2. Okay, so let's draw some axes. And we'll start from there. Well, actually, before we do that, let's look at what kind of transformations are occurring. So our parent function is sine theta. And then we have a plus 2. So this is plus 2 is a vertical translation up 2 units. The amplitude of our transform function is still the same. It's 1, so it's the same as our parent function. The period is also the same and remains at 360 degrees or 2 pi radians. Okay, so with that in mind, let's draw our axes in. All right, let's mark off some points. Let's say there. Let's label things. Let's mark off some values along the vertical axis. I think we might be running out of space, but let's give it a try. 1, 2, 3, 4, y-axis and -1, horizontal axis is theta. And let's start by drawing in our sine function. So our parent function. Okay. So sine at 0, 0, 90 it's 1, 180 it's 0, 270 it's -1, 360, 0. So this yellow curve is our sine function. Okay. So with our sine and cosine functions, they oscillate about a horizontal axis. So the parent function oscillates about this horizontal axis, or when y equals 0. So we have a vertical translation up 2 units. So that horizontal axis that the function oscillates about is going to shift up or be translated up 2 units. So why don't we start with that? That will be our first item that we translate up. So that axis now becomes y equals 2. Oh dear, I'm not sure what's happening there. I'll call that y equals 2. All right. So now this yellow curve, everything's going to be shifted up 2 units and is going to oscillate about this new axis. So let's pick another color. Let's say pink. So when theta equals 0, everything shifts up 2 to 2. When theta equals 90 degrees, we're at our maximum, that's shifted up 2 units to 3. When theta equals 180, we're back at our axis. When theta equals 270, we're at our minimum. So everything is shifted up 2 units to 1. And finally, when theta equals 360, we're back at our axis, which is this line, y equals 2. Join everything with a nice, smooth curve. Oh, we didn't. Let's try that again. Let's see if we can hit all the dots. And this pink curve, this bright pink curve is our transform function, y equals sine theta plus 2. Good. All right, let's scroll down. Let's see what we have next. Next, we're asked to graph y equals cos of theta over 3. Okay. So let's have a look at what's going on here, what kind of transformation this is. This transformation, we're taking our theta value and dividing by 3. So this is now a horizontal compression or stretch. It's actually a horizontal stretch by a factor of 3. So this is going to affect our period. So our new period is old period divided by this stretch factor or compression factor, stretch factor, which is 1/3. So 360 divided by 1 over 3 is 1080. The amplitude remains the same. Nothing else changes. Okay, so now let's start our graph. Let's draw some axes. Okay. Let's mark off a few points along our axis. We're going to end there. 1080. All right, we're going to divide into 3. 60. I think that's 720. And we're going to divide each third into quarters. Okay, and let's do some labeling. Mark off our max and min values. Okay, let's see what we have here. 360. Okay, let me see. Okay, a couple of calculations here. plus 270 and 810. So these are our interesting points. Okay. All right. So now let's do some graphing. So first we're going to graph our cosine function, or just our basic parent function, which is y equals cos theta. Let's do that. So when theta equals 0, cos equals 1. 90 at 0, 180 at its minimum, -1, 270 back to 0, 361. So let's just do that. Just mark in these dots all the way down. Okay, so this is our parent function. All right, so now let's consider our stretched function. So one cycle, so why don't we actually draw this in? Let's draw in one, whoops. All right, so this is one period of our parent function, y equals cos theta. Our transformed function, we're taking this one period and we're stretching it out over 1080 degrees. Okay, so again, when theta equals 0, our cosine value is 1, it's maximum. However, it reaches its minimum at 270, and then it reaches the axis 0 at 270, its minimum at 540, goes, that's right, back to its axis, back to the axis at 810, and then back to the maximum, starts its period all over again at 1080. So we're going to join these red dots, but oh dear, I'm not very good at joining dots with a nice red curve. So this blue curve, one period, has been stretched out to this red curve. So what I'm going to do is I'm going to finish joining all the blue dots so we can see how many periods, or what it looks like. So our parent function, the blue one, y equals cos theta, parent function, we're comparing this to our stretched out function, y equals cos of theta over 3. What a difference. We definitely can see the horizontal stretch. Good. All right, so this brings us to the end of our session. If you have any questions, send us an email at info@raisemymarks.com or give us a call day or evening, and we'll be happy to answer your questions. Thank you for watching, and we will see you soon.